to trigonometric principles. Trigonometric ratios, you guys already know this stuff from year 9, year 10. Of course, we have sine is opposite over hypotenuse. We have cosine, which is the adjacent, over hypotenuse. And of course, tangent, which is the opposite over adjacent. Now, the x values show our cosine, and while our y values show our sine values. And hopefully that sounds reminiscent of something you guys did last year, particularly a reference to our asterisk, which is our all sine, a tangent, and cosine. So we're saying, for example, if it's a sine in a certain quadrant, would it be a positive or negative value? But we'll refer to that in a second. So our cosine is our x value and the sine is our y value. So for example, if I pick this point in particular, the x value here would equate to our cosine, whereas our y value here would equate to our sine value. Okay. Let's move past that. I'm only going to fill in the first bit of the table. Now, I'm going to go through, again, the way that I do it. If you want to just memorize it, that's fine, but you guys know I have horrible memory anyway. So the way I remember it is to just make the triangles and then base it off that. Yeah. So all I have to do is draw one. That's an awful triangle. Let's draw one. Pretend that's a it's isosceles. 1, 1. And if those sides are 1, what does the hypotenuse length have to be? Root 2, yeah, it's just square root of 1 square plus 1 square, which is Pythagoras Theorem. So we end up with root 2. Now, of course, assuming that my triangle is perfect, what are the angles on the inside here? It would be 45 degrees, wouldn't it? Right, so pi on 4. Hopefully you guys remember that pi, and what does that little c up the top mean? Radian, great. Pi radians equals to 180 degrees, right? And of course, intuitively, 2 pi would imply 360 degrees. The other triangle, I'm going to show you guys the full way of finding this triangle. You don't have to do this every time, but I'm just going to draw I need to get better at drawing triangles. There we go. I'm going to draw this, which has sides of 2, 2, 2. Happy with that? I'm going to cut it in half so that I get a right angle triangle on this side. Of course, that means that because I cut it in half, that side length is now 1. If you use Pythagoras Theorem, you'll end up with root 3 here. If you don't believe me, you're welcome to do the Pythagoras Theorem yourself. So we end up with the triangle, and I'm going to try my best to make it look proper. There we go. It looks something like this, where we have 2, the right angle triangle with 1 on the bottom and a root 3 on the side. And then, because we've cut it in half, before, it had 3 equal angles, didn't it? Right? And each angle, because it's a total of 180, each angle will be 60 degrees. Which means that each one of these is pi on 3. But we cut the top one in half, didn't we? So half of that would be pi on 6. I know I've written very tiny. Can you guys see that off the back? Great, okay. So, let's start with filling these ones in here. Okay? So, pi on 6. Sine of pi on 6, so the opposite over the hypotenuse. So, pi on 6, look at this angle here. Hopefully this seems quite reminiscent. Pi on 6, opposite, which is 1, over the hypotenuse, which is 2. If I go the other way and say, okay, well, I've got pi on 3. Let's look at the opposite, which is root 3, over the hypotenuse, which is 2. If I use the pi on 4 one, which of course these two are the same angle, by the way. If I look at the pi on 4 opposite, over hypotenuse, 1 over root 2. Now, how do we fill in pi on 2? How do I find what sine of pi on 2 is? Which ordinate does the sine value represent? Y. Good. Y. At pi on 2, what is the y value? 1. So that's it. 1. And what would the y value be when we're looking at 0 degrees or 0 radian? 0. Great. And we can do the same thing for our cosine values and for our tangent values. I'll get you guys to fill that in yourself when you have time. Okay. These are just the same thing, but like what if I had more than pi on 2, which you guys can fill in later as well. Alright, symmetric properties of circular functions. So for this section here, we're really focusing on whether you remember how symmetrical or how symmetry works in a unit circle. Can we find, for example, there we go, if I've got a value or a degree or a radian larger than pi on 2, can I find that value regardless? And there's really only a few steps you need to apply. Okay? The first step is figure out which quadrant it is in. Second step is figure out what the reflective or the reference angle would be. So in this case, tan of 7 pi on 4. Does this kind of question sound familiar from what you guys did last year? Yeah. That is similar, I would say, or the same as to tan of 8 pi on 4 minus pi on 4. Agreed? Great. I know that's the same as 2 pi. And if I draw my unit circle out as the best of my ability, we can say that 2 pi goes all the way around here, because we always start when we say degree 0. It goes all the way around, and then we take away pi on 4. So we go back pi on 4, which should give us an approximately, there's an awful diagram, an approximately, or should be 45 degrees negative, right? So it makes sense that the tan value of that is the same as if I was, instead of going all the way to 2 pi and back pi on 4, I can just go back pi on 4. So let's go back up here. Let's figure out what tan of pi on 4 is. So tan of pi on 4, so tan is opposite over adjacent, isn't it? So opposite over adjacent gives me 1 on 1, or rather just 1. So let's go back down. So we're saying, all right, we've got tan of pi, I should write tan negative pi on 4, apologies. Okay, and I should say, because I know that tan of pi on 4 is just 1, I'm going to write 1. Now, which quadrant was our answer in, our degrees or radian in? It was in the 4th quadrant, wasn't it? Is tangent positive in that quadrant? No, and we know that because of our, Daniel, what's the acronym? ASTIC, right? You have to say it with emphasis. Of course, so cosine's the only one that's positive, so therefore we should write -1. Would you guys like me to do one more example, or just move on? One more. Great. Let's do sine of 23 pi on 6. Again, I know it's very close to 24 pi on 6, which is actually a really good multiple. So let's do that. I'm going to write equals sine of 24 pi on 6 minus pi on 6. Please note that sometimes you might plus pi on 6 instead. It's up to you. You could go, for example, 18 pi on 6 plus 5 pi on 6. It's up to you. Though 18 is a bit odd because when you divide it by 6, or divided by 2, sorry, you end up with an odd number. But anyway, let's keep going. So equals sine of, which I know 24 pi on 6 is the same as 4 pi on 6. So 4 pi, my apologies. And we end up with that. And of course, 4 pi being a multiple of 2 pi means it just go around twice. So if I was to draw it out, I'd go 1 and then 2. Right? And then we do our negative pi on 6. Right? So it's the same as saying sine of negative pi on 6. And I can show that graphically. Then we do the same thing we did before. What was sine? Of course, our reference angle was pi on 6. So what was sine pi on 6? Well, it was half. So I would just write equals half. Are we done? Why not? Sorry? Why is it minus? Great. Well, it is negative pi on 6, but also, because negative pi on 6 gives us quadrant 4, is sine positive in quadrant 4? No, of course not. Only cosine is. So therefore, we would write negative half. Any questions about that? Great. I'll come around and help you guys out with that in a moment if you need it. Alright, so next one we're looking at example 2. Alright, this one's a little bit weird, but it actually refers to our complementary relationships. Now, this is stuff that you guys can tell based off the unit circle itself, but I'm going to ask you guys to write this into your notebooks regardless. Can I get you guys to write down sine pi on 2 minus theta equals to a or cosine theta? And also, write down cosine on pi on 2 minus theta equals b, which equals to sine theta. And I'm going to ask you guys, try your best to draw a diagram that's as visually perfect as mine. I hear chuckling. I don't know why there's chuckling. Alright. Wow, that is awful. Hoping you guys can do a little bit of a better job than I can. Alright, so in this diagram, while you guys are writing that down, in this diagram, please note, of course, we've got theta being our standard angle, and the other side, where we've got theta coming down, is equivalent of saying pi on 2, so 90 degrees, minus theta, same thing. And we end up with the same, if you want to call it like a flip triangle. And you also know that A is the horizontal distance, so the x value, whereas A on the other side would be the vertical distance, but again, it's the same value. And B is the opposite. So sine of pi on 2 minus theta equals to cosine of theta. And you can see that in the relationship shown, and you can apply cosine, sine, see whichever ratio works, and you get the same thing. So sine pi on 2 minus theta equals to cosine of theta. So in this question, I've been given sine theta equals to 0.3 and cosine phi equals to 0.8. Find the value of sine pi on 2 minus phi. Of course, using the formula, I know that sine pi on 2 minus phi equals to cosine of phi, doesn't it? Just using my formula. Just using my formula, which I know is 0.8. Now, does it make sense for that to be in the first quadrant? I mean, it does, doesn't it? So let's move on from there. Now, this next one requires another 2 formulas. Same drawings. However, I'm going to ask that you guys write this down. Sine pi on 2 plus theta equals to cosine of theta. There we go. And cosine of pi on 2 plus theta equals to negative sine theta. So again, this is stuff that you can tell based off the unit circle, but if you can have a formula, you can just apply algebraically and be done with it. So in this case, instead of going less than pi on 2, we're going greater than pi on 2. Similar principle applies anyway. So using these formulas, we can solve a question like this and say, well, if cosine pi on 2 plus theta, well, I know using my formula, that's the same as saying negative sine theta. Same as saying negative sine theta. And then, therefore, I know that's just got to be negative 0.3, because in the question it told me sine theta is 0.3. Great, I can call it a day and be done with it. So instead of using all these, this understanding of the graphical thing, we can just use the formulas provided to us and then apply it there. I do want to give you guys a heads up. Unfortunately, there are a lot of formulas to know for trigonometry, particularly when we go down to the more difficult trigonometric ratios, but we can worry about those later down the line. Speaking of trigonometry formulas, can I get you guys to write down the next formula as well? This one's a really quick one. There we go. So cosine squared theta plus sine squared theta equals to 1. This may or may not seem familiar to you guys. This is what we call Pythagorean identity, by the way, if you're curious. It's kind of like a squared plus b squared equals c squared. That's literally it, by the way. With a hypotenuse, there's always going to be 1, isn't it? In a unit circle, that's why it's called a unit circle. The hypotenuse is always going to be 1. When 1 squared is always just 1 anyway. So we have 1 is the same as a squared plus b squared. In this case, of course, we know that x is our cosine. So cosine squared plus sine squared, which would be the same Pythagorean identity applied to our unit circle. Given that sine equals a negative 5 on 13, and pi is x is between pi and 3 pi on 2, find cosine and tan. I'm going to focus on finding cosine because tangent is pretty straightforward after that. Well, I know that cosine squared theta plus negative 5 on 13, I know that because I'm just using the formula, sub e and sine x, squared equals to 1. Now, if I get my fancy class pad out, and I can put that in the calculator, put it out into the calculator. There we go. We can put that in the calculator and say, alright, so we got, and let's just call it, you know what, let's just rearrange it. So I'm going to get cosine squared theta equals to 1, and going to minus negative 5 on 13 and both squared on both sides. So get 1 minus brackets negative 5 on 13 squared. There we go. Which equals to 144 over 169, which to me looks like two perfectly square numbers. Which means we can square root both sides. I can get, say, cosine of theta equals to square root of 144 over 169, remember plus or minus, which equals to plus or minus 12 on 13. Now, how do we decide whether it's plus or minus? Is there information that we've not used in the question yet? Well, yes. Domain, thank you very much. So the x value, or the angle that we've been given, must be, and it says pi to 3 pi on 2, so that's 0, pi on 2, pi and 3 pi on 2. So if it says between pi and 3 pi on 2, of course, it means it must be in this domain, this quadrant. And if it's in that quadrant, according to my ASTK, is it positive or negative? Negative. So therefore, cosine theta equals to negative 12 on 13. Now there's a relevant formula to try and figure out tangent. Does anyone know what the formula for tangent is? If I know what sine and cosine is, how do I find tangent? Thank you very much. Tan theta equals to sine theta over cosine theta. So again, another formula or identity that you have to memorize. I know, but this one, well, these last two ones are pretty straightforward. Any questions? Okay.